Yeah. Thanks, Patricia. Perhaps you know me from this morning presentation case study 3. I will, in the following, present you the work package 4, and will broaden also a bit our mind what it is actually about, because it goes a bit further than only the Chimera extraction. Okay. So here a quick overview. I will give you a quick graphical overview what work package 4 is actually about, describe the task that we have, go a bit into the first year planning, highlight interlinkages with other work package, and then at the end I conclude with risks and mitigation measures that we have in our work package. We have some partners here in our project. That is, the leader is TU Delft. I will coordinate this package. Royal Haskoning, Vetsus, Acciona Aqua, Aquas do Algarve are there, and unofficial partners are Distrikts Rheinlanden and Chaincraft, who will support us during the project. Well, I think this morning we heard already about the narrator technology. I hope that is now clear to everyone that it's an excellent way on how to clean your wastewater with a very small footprint, and there are more than 70 installations, I think, worldwide that are there now, and it works quite well. But there's also one disadvantage about this narrator process, and that is we produce this granular sludge is partly also the end product, the waste product. And in many places it goes nowadays to a fermenter where you produce at a neutral pH biogas, and that is usually incinerated on site to produce energy at the treatment plant. And the remaining sludge after this fermentation is brought to an incinerator usually, and there it's burned to gain some heat, but also to destruct the contaminants which are still in the sludge. So that could be, for instance, microplastics or residuals of pharmaceuticals. But along this destruction, you actually also lose your phosphorus and nitrogen, which are valuable resources, which can be used as a fertilizer. So what we envisage actually in our work package 4. Here again, the problem is it's non-circular, the narrator. But what we envisage is actually, first of all, this granular sludge, we don't want to send it completely to the fermenter, but before that, we would like to extract the Chimera, to have this biopolymer that we are using then to substitute oil-based products. And that is actually a high-value product already that we are producing. Since the extraction of the Chimera takes place at alkaline pH, we can also do the fermentation of the sludge at a high pH. And the advantage is we don't get biogas, but we get methane, meaning that CO2 remains in solution and only more or less pure methane is yielded. And so that's also a higher value product. So at the end of the day, we would like to get 2 high value products instead of a low value product. And on top of that, we would not only like to recover high value carbon products, but also get phosphorus and nitrogen out of the sludge or of the sludge liquid, and to produce, for instance, fertilizer out of that. And so in our demo, this Chimera is basically already there, the extraction. So it's already happening on 2 pilot installations in the Netherlands, one on municipal wastewater sludge, and one is working with sludge that comes from a narrator plant that works on dairy effluent. And this alkaline fermentation and the recovery of phosphorus, that will actually be tested and evaluated in our project. So there we really go a new direction. And of course, our target is also to always keep in mind the nitrogen recovery. So what we envisage is a Nareda plant with an excellent wastewater treatment performance, but also a circular use of the valuable resources that are still in there and that are currently often lost. And we have quite some objectives there, of course. I don't want to go in every detail in it. The main point is that we build a transportable and optimized Chimera extraction unit. I think I also spoke about this morning about it, so that it should be able to bring it from one place to another, make some publicity for circular use of resources from wastewater treatment plants. We would like to optimize it based off the experiences that are made with the other plants in Netherlands. We implement this plant then in a cold and warm climate region. That was Utrecht and Porto, which I mentioned this morning, and extract some Chimera from it. And then we would like to characterize this Chimera and compare if there are actually differences between the different areas. And of course, it's not only the climate, but also like the salinity is different in Netherlands, in Dutch wastewater compared to Portuguese wastewater. And of course, we look also at the products. So first you have the Chimera that you characterize, but also you look, okay, what kind of different applications are there, or do we need to define different applications depending on which site we are? We characterize the fermentability at high pH of the residuals from this Chimera extraction. So that's really something that we try on a bench scale or lab scale in our unit. So we try to integrate it in our demo. And at the same time, we investigate the possibility to recover phosphorus from our sludge. And that hopefully we can give some recommendations at the end of the project and maybe even implement a little lab test there. And of course, we also looking really forward to work with the other work packages and hopefully to create a lot of synergies there, because as we heard from Mark this morning, it's not only what we do as engineers or biotechnologists, but also what then the society, what politicians do. And I'm really interested in that. And based on that, we have also some deliverables, and that will be that we start with the operation of the demo, I think latest after 18 months, but of course we hope to do that earlier. We deliver a report about the quality of Chimera and its products. And we deliver 2 further reports on the experiments that we made with the alkaline digestion of the organic residuals. And of course about the phosphate recovery options that we figured out hopefully by then. And of course, throughout the project, we deliver technical results and reports to the other partners. And of course, I look also forward to discuss this in further detail later on during one of the breakout sessions. And the milestones that we have is first designs on the demo that we have, meaning drawings that we deliver. Then the startup of the operation of the demo, and some patent filling and in the 3rd year. And then also the environmental technology verification. The tasks that we have is, of course, also linked to the other deliveries and milestones that I discussed before. I don't want to go in very much detail into that. I think that can be also looked up online. What you see here is basically who is involved, who are the leaders. In task 4.1, the leader is TU Delft, and there's Royal Haskoning DHV involved. And later on at the installations, when they come to the different sites, of course, the operators, which is Aquas do Algarve and Royal Haskoning DHV. And when we later on compare the Chimera from the different regions and also the products, we involve chain craft, which is really strong here. And leader, and for all the other tasks, TU Delft is leading, except of task point 4.4. There is Wetzels the leader. And together with us, with TU Delft, we hope to develop a strategy there. And the coordination of work package 4 with the other work packages will be done by all partners which are involved in work package 4. Yeah, our first year planning, there's actually not so much going on. There's one deliverable at month 12. But of course, our main business will be to design this installation. And also, when we do that, we of course like to also keep in mind that there's nitrogen and phosphorus recovery and the alkaline fermentation that should be included at the end of the day. So our first step will be from end of this month on to really get this going and meet frequently with the Royal Haskoning DHV, who are supporting us with the design and the building of the plant. And we are actually planning to meet 3 times per year with the whole work package. And then we have on the task level, so for instance, when we are planning on designing the installation at the beginning, we meet 2 times or so per month with Royal Haskoning DHV. And we will also involve the other partners, of course, and keep them in the loop. And by the way, we didn't have our kickoff meeting yet. We will have this next week because we first wanted to check a bit how that is going here and what information we can take along for our kickoff. And of course, there will be this monthly reports to the project management team where I will be responsible for. There are plenty of interlinkages with other work packages. That is a monthly report to the project management team, the general assembly that will take place once a year. And of course, we have the social embedding, where I will take part in the social workshops. There will be a data collection system. And of course, there's also interactions with the other work packages that we will discuss this afternoon. I want to end up with the risks and mitigation measures that we have. Of course, there's in general a lack of coordination is a risk. I think we will take care of that, and there is also the higher project management team which will take care of that, so that the probability is quite low. For the resources of the partners, I think the risk is also low, that because we can make adjustments throughout our project. The technological risks are that there are delays in construction and installation of the demo. And I think there we are in close collaboration with the project officer and can adjust the timelines and objectives in the worst case. And of course, we will carefully control that throughout this designing process. And I also think that the system will work because there are already pilots out there that work, and we can learn from them and should be able to get this going. And that was it from my side. Thank you.
Thank you very much, Philipp, for your contribution. We have a question from Sanjay, and he's asking, what is the minimum and maximum organic loading of wastewater required for Nereda Chimera technology to work?
I don't know. I would give this question to Mark, but
minimum and maximum organic loading.
Okay. So the Chimera extraction installation doesn't need a minimum or maximum organic loading because that's the extraction of the Nereda sludge. And the Nereda installations, they run at a moderate loading rate for municipal wastewater treatment plants.